Okay, in this video we are going to do some multiple choice series problems that are based on previous AP exams. They're not actual problems from old exams, they're just based on them. I'm going to go through how I solve them, and sometimes I'm going to look at answer choices, sometimes I'm just going to straight up solve them, talk about like taking multiple choice tests and doing series problems at the same time. So there's a link in the description to the problems and maybe to some timestamps, but that takes a long time, so maybe not. All right, let's get started. So first question is, which of the following series can be used with the limit comparison test to determine whether the series, the sum of n cubed over n to the fifth plus 2 converges or diverges? So first thing I think with limit comparison is like, what does the series overall look like? So I'm going to knock off anything other than the dominant terms in the numerator and denominator. So I'm really going to look at n cubed over n to the fifth, because that plus 2 in the denominator doesn't really do anything as you go to infinity. And n cubed over n to the fifth would simplify to just 1 over n squared. And 1 over n squared is an answer choice, and I could definitely limit compare with that. And I would find that it converges, but that's not actually the question. So I'm going to circle that. So what you're doing is you're going to figure out what it basically looks like and then use that for limit comparison. But you have to know what it basically looks like does, right? So 1 over n squared is a p series, p is equal to 2, which is greater than 1, and therefore it converges. So not really the question, but if it had been the question, I would have said it converges by limit comparison to 1 over n squared. All right, let's take a look at another problem. So p of x is 4x squared plus 3x cubed minus 8x to the fourth plus 2x to the fifth. This is the fifth degree Taylor polynomial for the function f about x equals 0. What is the value of the fourth derivative at 0? All right, so I am going to do this by knowing Taylor's theorem, right? So that says that I need the coefficient of x to the fourth is the fourth derivative at 0 over 4 factorial. That's basically what I'm going to do. So the coefficient of x to the fourth is negative 8, so I know that the fourth derivative at 0 divided by 4 factorial is equal to negative 8. And if I multiply across, I'll get that the fourth derivative at 0 is negative 8 times 4 factorial. 4 factorial is 24, and negative 8 times 24 is negative 160 minus 32, so negative 192. All right, so I'm going to circle that, and that would be my answer, and I would move on. But there's another way to deal with this, and that is that you can actually just remember that a Taylor polynomial matches the value of the function and the value of the derivatives of the function at the center. So you could actually just start with the original, and I'm going to take the derivative 4 times. Well, I'm going to take the first, second, and third, and fourth. Yeah, I'm going to find the fourth derivative. So I'm not going to make you watch that, but power rule it, power rule it, power rule it one more time, and now evaluate this at 0 to get the fourth derivative is negative 192. Get the same answer either way. Sometimes the second way is really impractical. Like what if it was the 25th derivative? What would you do then? So it's really useful to know that the nth derivative evaluated at the center over n factorial is the coefficient of, that should really say the quantity x minus c to the n, but it's you just find the power you're looking for, and that coefficient is the nth derivative over n factorial. So that's how I would have done this problem. All right, let's take a look at another problem. The third degree Taylor polynomial for f about x equals negative 2 is given by quantity x plus 2 cubed over 252 minus 3 over 25, the quantity x plus 2 squared, plus 24, the quantity x plus 2, and then plus 8. What is the value of the second derivative at negative 2? All right, so this is like basically the same question, right? So I'm going to find the coefficient of the quantity x plus 2 squared, which is negative 3 over 25, and then I know that that is the second derivative at negative 2 divided by 2 factorial. So we set this up, and then I'm going to multiply by 2 factorial, which is just 2, so I will end up with the second derivative at negative 2 is negative 6 over 25. And that's our answer. I'm not even going to look at the other answer choices, really. B is like the obvious wrong choice, where you just like see that coefficient and go for it. I think C is if you like I don't really know, like you divide by 2 instead of multiplying by 2. I don't know why you would do that. A is like you just saw the numerator and went with it, I guess. So it turns out I am going to look at the other answer choices. All right, let's take a look at another one. So the radius of convergence of the power series, the sum of x minus 5 to the 2n over 2n plus 3 is equal to 1. So we know the radius of convergence. And what is the interval of convergence? So what I could do is, I could like do this. Like I know it's centered at 5 and I can go 1 in either direction. So that's going to give me 4 and 6. And now I have to test the endpoints. But if you look at the answer choices, they already gave you the endpoints. And all you have to do is check convergence. So let's check convergence. So I'm going to start with x equals 4 because every option has 4. So if x is equal to 4, the series itself is going to become the sum of negative 1 to the 2n over 2n plus 3. Negative 1 to the 2n is just 1. So it's the sum of 1 over 2n plus 3. And that I know diverges. If I had to say why it diverges, I would say it's basically the harmonic series. But if I had to be formal about it, I would say it diverges by limit comparison to 1 over n, which I know is the harmonic series and diverges. And I would do the limit of the ratio. I would get 1/2. 1/2 is positive and finite. They're the same, so they do the same thing. All right, so I know that at x equals 4 it diverges, so I can cross out anything that had it converging there. So b and d are gone. Now I need to test 6 in the same way. So take 6, plug it in for x. We get 1 to the 2n over 2n plus 3. 1 to the 2n is just 1. So we have 1 over 2n plus 3. And I know that that diverges it's the exact same series, so for the same reasons. So I can cross out anything that involves 6 converging, which would be C, but I'm just going to circle A, which is the answer. So you always want to take a look at the answers when you're doing these problems because you're taking a multiple choice exam when you're on the AP exam. So you actually have the answer in front of you somewhere. You just have to figure out which of those options is the answer. All right, let's take a look at another one. The interval of convergence of this thing, so the quantity 2x plus 1 to the n over 4 to the n is, and again, we have the answers in front of us, so instead of like doing the problem like straight up, I'm going to like look at the answers and work for those. So I see negative 3 is the most extreme answer here, so I'm going to see what happens at negative 3. But notice the answer choice doesn't have it converging at negative 3, but I'll talk about that in a second. If I sub in negative 3, I get negative 5 to the n over 4 to the n, which would give me a geometric where r is negative 5/4, and the absolute value of that is greater than 1. So it definitely diverges there. But the answer choice said that it would diverge there. But like, what if we use negative 2.999, right? That's in that interval, but it's still going to give you basically r is negative 5/4. The absolute value of that is still greater than 1. Still diverges, so like there's no way this could be the answer. So I'm going to cross that out. All right, now I'm going to look, I think that I get a lot of benefit from trying to figure out if this thing converges or diverges at 3/2 because 2 of the answer choices are essentially the same, which is suspicious. And one of them has it converging, one has it diverging at 3/2. So let's just see what happens at 3/2. So if x is equal to 3/2, the series is going to become the sum of 4 to the n over 4 to the n. Well, that's just the sum of 1, and that definitely diverges, right? Because you're doing 1 plus 1 plus 1 plus 1. How could that have a finite sum? So that diverges, which means I could cross out C for sure. But if 3/2 diverges and the center is negative 1/2, then 2 is definitely going to diverge, right? Because it's outside of whatever interval I might have, because it has to converge at the center, and it already diverges at 3/2, so it'll diverge at anything bigger than 3/2. So it diverges at 2, so I can also cross out A at this point, and then I can just pick B as my answer. I never even need to test negative 5/2. If I did test negative 5/2, it would be negative 5 plus 1 is negative 4. So I have negative 4 to the n over 4 to the n. So I get the sum of negative 1 to the n, which is just going to alternate. So it's going to start at So negative 1, it starts at 0. No, it starts at 1. But then you subtract 1, then you add 1, then you subtract 1. It's never going to settle into a number, so it definitely diverges. But we already knew that the answer was B. All right, let's take a look at another problem. For what values of x does the series, the sum of the quantity 3x plus 1 to the n over n factorial converge? I'm going to do the ratio test on this. I enjoy doing the ratio test. It's my favorite test, and it's really good practice. So let's see if we can do it. So before I use the ratio test, I like to rewrite this thing so that I get like everything to the n that can be. So like every base raised to an exponent. And also, I like the coefficient of x to be 1. So I'm going to take 3 out of everything in parentheses there. So it'll be 3 times the quantity x plus 1/3. And then to the n gives me 3 to the n, quantity x plus 1/3 to the n, all over n factorial. All right, now I'm going to do the ratio test with this. So it's the limit as n approaches infinity, the absolute value of the n plus first term, so all my n's become n plus 1s. So 3 to the n plus 1, x plus 1/3 to the n plus 1, over n plus 1 factorial, and then times the reciprocal of the nth term, so times 1 over a sub n, which you just take a sub n and flip it over. So we get this. All right, so you get a lot of things that cancel, which is what I actually enjoy about the ratio test. So we'll have the limit as n approaches infinity of, so 3 to the n plus 1 over 3 to the n is just 3. I still need to keep absolute values because x could be like anything that at this point, we have no idea what's going on. So it's going to be the absolute value of x plus 1/3. So the x plus 1/3 to the n canceled with x plus 1/3 to the n, and we're just left with x plus 1/3 to the first, but we keep the absolute value. And then n factorial over n plus 1 factorial is just n plus 1. All right, x is a constant because n is the variable, because n is approaching infinity. So we have basically a constant divided by n plus 1. That's definitely 0, which is less than 1 for all values of x, which means x could be anything, and this thing will converge as long as x is finite. And so x must be an element of the reals. All right, let's take a look at another problem. The power series, the sum from 1 to infinity of the quantity x minus 2 to the n over 3 to the n times n cubed has a radius of convergence 3. There's a lot of n's in this problem. No, there's a lot of 3's. Well, there's also a lot of n's, but 3's are really what's throwing me. Which of the following values of x can the alternating series test? So this is interesting. We have to be able to use the alternating series test, be used with the series to verify convergence. All right. So what does this series look like, right? It's centered at 2, and then we're told the radius is 3. So what I like to do is I like to actually draw a number line so I can see this thing. So center at 2, I can go 3 in either direction, which means I can go to -1 here and 5 here. Definitely converges everywhere on the interval. The question is, like, at the endpoints, does it converge or diverge? But let's see what the answer choices are to see how we can do this, right? So I know that between -1 and 5, it definitely converges, definitely diverges everywhere outside of that. -2 is not on that interval, so that's out. Can't be it. At this point, you could like really quickly look at them and think about it and kind of know the answer, but I'm going to test them all. I mean, the answer is going to end up 0, but I'm going to test them all. So if x is equal to 4, which is in the interval, my series becomes 2 to the n over 3 to the n times n cubed. That doesn't alternate, so the alternating series test cannot be used. So that's out. X equals 2 is actually the center of this thing. At x equals 2, we basically just get 0. So we're just like kind of adding up 0. That does not alternate, so that's going to be out. And that means that the answer must be just this. If we did sub it in at 0, we would get the sum of -2 to the n over 3 to the n, and then n factorial. That definitely alternates. And so we could use the alternating series test on it. So that would have been our answer if we had tested it, which I guess it did. But on the actual exam, I would have circled 0 and moved on a long time ago. All right, let's take a look at another problem. The infinite series, the sum of a sub k, has nth partial sum s sub n equals 3n over 5n plus 4 for n greater than or equal to 1. what is the sum of the series sum of a sub k? All right, so this is kind of interesting because they've given us the nth partial sum. And if you remember when you're learning series, it's like the first thing you think about is like, what are the partial sums doing? And so you try to come up with a formula for the partial sums. And then if the formula for the partial sums converges to something, then the series converges to that. So to solve this problem, all I really need to do is take the limit as n approaches infinity of s sub n. So the limit as n approaches infinity of s sub n, or 3n over 5n plus 4, is definitely equal to 3/5. You have a lot of options to find that. You could look at it and know it. You could use L'Hopital's rule. You could divide through by the highest power in the denominator, the highest power of n in the denominator, which is n. You would get 3 over 5 plus 4 over n, and then take the limit. Either way, anyway, you're getting 3/5. So that is the answer. If this limit was infinite, then the series would diverge. I don't know how you would get 1 or 1/3 out of this. I don't know. I guess maybe you could get 1 if you thought you had to like ratio test it. That would be really weird. But I don't know where you're getting 1/3. So anyway, that's my answer, and let's move on. What is the radius of convergence of the Maclaurin series for 8x over 1 minus 2x squared? Okay, so to do this, you want to have done a lot of problems before, so that you look at this and you just realize, like, I know a thing that I can do. I look at this and I think that it's really just like 8x times 1 over 1 minus 2x squared. And then 1 over 1 minus 2x squared in my mind is like the sum of a geometric series. So let's rewrite this. So I'm going to write it as 8x over 8x times 1 over 1 minus 2x squared. All right, and now what I'm going to do is write a series for that. But that's like a perfect sum, right? Because it's 1 over 1 minus r is the sum of a geometric, or it's really the first term over 1 minus the ratio. So I know that r is 2x squared. So that's going to be r. So I'm going to write this as 8x, the sum of, and then it's r to the n. And like n starts at 0 and goes to infinity, but for the radius of convergence, that's not actually relevant, so I'm not going to worry about it. So all of this is based on the fact that I'm saying r is 2x squared. And for this to converge, I need the absolute value of r to be less than 1, which means I need the absolute value of 2x squared to be less than 1. So that means that just x squared is always positive, so that absolute value you can kind of drop it. Just x squared has to be less than 1/2. And then if I square root both sides, I get the absolute value of x is less than square root of 2 over 2. Or you could break it out. For some reason, I decided to write it this way. Negative root 2 over 2 less than x less than root 2 over 2. But the radius is definitely root 2 over 2 because the center is 0 and you can go root 2 over 2 in either direction. So that is our radius. All right, let's take a look at another problem. If a sub n is equal to the secant of pi over 2n for n equals 1, 2, etc., which of the following statements about the sum of a sub n must be true? All right, so what are the statements? Let's see. Series converges and the limit as n approaches infinity is 0. I mean, that's possible. The series diverges and the limit as a sub n approaches infinity is 0. That's also possible because the n-term test can only tell you divergence. So if you get a limit of 0, you have no idea. If you get a limit of 0, maybe it converges, maybe it diverges. We don't know. The series converges and the limit is not 0. That's actually not possible. We could cross that out right now. I'm not gonna, but we could. The series diverges and the limit is not 0. Yeah, I mean, that could definitely happen. So I'm going to find the limit and see what happens. So the limit as n approaches infinity of a sub n. So we get this limit is, all right, so if n goes to infinity, pi over 2n just goes to 0. So this is basically saying, like, we're finding the secant of 0. If you remember your unit circle or your basic trig stuff, the secant of 0 is 1 over the cosine of 0. The cosine of 0 is 1, so this is 1. All right, so now we know that the limit is not 0. So we can cancel out any option where it said that the limit was 0. So this and this. All right, so the limit is not 0, which means that the series cannot converge, right? Because eventually you're just adding plus 1, plus 1, plus 1. That's not going to converge. So the answer must be the series diverges. So let's get rid of that. Let's circle that. All right, I am going to pause here. You don't really need to know that, but I need a break. I'm going to come back and do a lot more problems in the same video, but I'm taking a break for a second. Okay, I'm back. Let's do another problem. So I guess we're up to problem number 11. All right, what is the coefficient of x to the fifth in the Taylor series for 2x over the quantity 1 plus x squared squared about x equals 0? All right, so these problems, depending on how you go about these problems, they can be a lot of work. You want to have done a lot of practice problems so that like you see something like this and you think like, I definitely got this. So I am going to approach this problem by thinking 2x over the quantity 1 plus x squared squared looks like something I could integrate. In fact, it looks like the derivative of something. And since it looks like the derivative of something, I'm going to try to integrate it. And when I integrate it, I'm going to try to write a series for that, then take the derivative of that. So this is like a thing you do sometimes. Sometimes you get a function or a function you want a series for, you'll take the derivative, write the series, and then integrate the series. Sometimes you will be given a function, you'll integrate the function, write a series, take the derivative of the series. In this case, I'm going to try to integrate. So I'm going to do the integral of 2x over the quantity 1 plus x squared squared dx. All right, so this, it turns out, is like a perfect integral, right? So if you let u equal 1 plus x squared, then du is 2x dx, and it's perfect. It's like you have your 2x, you have your dx, so this is just u to the negative second, which will integrate to negative 1 over u, so negative 1 over 1 plus x squared. And I guess there's also a plus c. We're going to take a derivative, so that plus c doesn't really impact us. Now I want to rewrite this so it looks geometric. I mean, it already looks geometric to me, but negative 1 over 1 minus the quantity negative x squared plus c. All right, I'm going to start ignoring that plus c because it's just a constant, and we're looking to take the derivative as we go. So let's write a series for this. So it's going to be negative sum of negative x squared to the n, which is going to be negative sum of negative 1 to the n, x to the 2n. I'm going to start writing out some terms. So n is starting at 0 because it's geometric. So it's negative quantity. And now I'm just plugging in 0, then 1, then 2, then 3. So I went out to that term because this is the series for the integral of what I want. And so to get to the fifth power, I need x to the sixth. So now what I'll do is remember that this is the series for the integral, and I'm going to take the derivative of both sides. So the derivative of the integral just takes me back to the 2x over 1 plus x squared, and then that'll be equal to negative, and then the derivative of this, so just power rule it. And the whole idea here was that I wanted that x to the fifth, right? Because I'm looking for the coefficient of x to the fifth. So the coefficient of x to the fifth here is negative 6, right? So negative 6. So the coefficient is positive 6. All right, so that's going to be my answer. So I'll circle it, and I will move on. There are many ways you could do that problem. That's the way I've chosen to do it. The next problem sort of like looks similar, which of the following is a Maclaurin series for 1 over the quantity 1 minus 2x squared. So I could actually do this the same way. I could integrate that, write a series, and then take the derivative, which would actually probably be easier than what I'm about to do. What I'm going to do instead, because sometimes you have to do this so it's good practice, I'm going to write a series for 1 over 1 minus 2x. And then I'm going to multiply the series by itself. So that's a clear case of a sum of a geometric series where r is equal to 2x. So a geometric series where r is equal to 2x is the sum of 2 to the n, x to the n, or the quantity 2x to the n. I like to break it out so that it's like every base with its own power. Let's write a couple terms of this. So this will be 1 plus 2x plus 4x squared plus goes forever. So if I were to square this, Squaring 1 over 1 minus 2x is equivalent to squaring this series that I just wrote. The issue is there's an infinite number of terms, so multiplying an infinite number of terms is pretty annoying. But we actually, because we're going to match an answer choice, we don't need to do that. So I'm going to set this up, I'm going to do 1 times everything, right? And I'm going to write that down. So that's 1 plus 2x plus 4x squared. Now I'm going to take 2x and multiply it by everything. So 2x times everything, so 2x, 4x squared, and then we'll get an 8x cubed. Now I'm going to take 4x squared and multiply it by everything. That'll give me 4x squared. And you keep going. So the key thing here is that you won't get any more x squared terms when you take the next term, which I guess is what? 8x cubed. Right? You're not going to get any more x squared terms. So we've locked in the constant term, the linear term, and the squared term. So let's see what those sum up to. So if I add those up, I get 1 plus 4x plus 12x squared. Plus, like, it goes on forever, but we locked in those. So I should be able to, looking at the answer choices, choose the answer. If you look, option C is the only one that has these terms, so that's our answer. So you can actually multiply power series. It's kind of annoying. But you can do it. All right, let's look at another one. Which of the following statements about the convergence of the series is true? All right, so option A, the series converges by comparison to 1 over n. Well, 1 over n diverges, so we can't use that. The series converges by comparison to 1 over n squared. That you could potentially do. Series diverges by comparison to 1 over n. That you could potentially do. Series diverges by comparison to 1 over n squared. You cannot do that because 1 over n squared converges. All right, so now we just have to decide, does this series converge or diverge based on comparison to the things we were given? I would like 1 over the natural log of n. I feel like it's really, really slow. I feel like it definitely diverges. So let's see if we can compare it to 1 over n. So my initial thought is, how does natural log of n plus 1 compare to n? Well, the natural log of n plus 1 is definitely less than n, like eventually. I don't even really need to know like for what values of n, but eventually it's definitely less than n. So just like graph them, and you can see that that'll be true. So if we take reciprocals, that flips the inequality. So 1 over the natural log of n plus 1 is definitely greater than 1 over n, and 1 over n diverges. So we could definitely use actually direct comparison and see that option C is the answer. So I kind of like felt like this should diverge because natural logs grow very, very slowly. So that's how I decided to go with C as my like thing that I was going to investigate more. And those are the kinds of insights that you want to like bring with you to the exam. So you have to think about these things a lot. That's how you gain those insights. Let's take a look at another one. The n-term test can be used to determine the divergence of which of the following series. So if the n-term test is telling me that a series diverges, then that's because the limit of the nth term is not 0. So I am going to start taking limits and see how it goes. All right, so let's start with the first one. Option 1, the limit as n approaches infinity of the natural log of k squared plus 3 over k squared plus 1. So if, well, I guess I should have done k goes to infinity. I always mess that up. So if k goes to infinity, then inside the natural log, you get just 1, right? That the limit of k squared plus 3 over k squared plus 1 is 1. So you get the natural log of 1. The natural log of 1 is 0, which means that the n-term test tells us nothing about this. So option 1 doesn't work. So let's cross out anything that has option 1. So that's B and D are out. So now we have to choose, it's either 3 or 2 and 3. So checking option 2 makes the most sense. So let's check option 2. Because at this point we basically know that option 3 like will work. So it should have been k going to infinity of negative 1 to the k, quantity k squared over k squared plus 3. So this, like, if k is going to infinity, eventually, because k squared over k squared plus 3 goes to 1, eventually you're just going to, like, oscillate between plus and minus 1. So, like, this limit doesn't exist. You're going to get positive 1, negative 1, positive 1, negative 1. That is not 0, and therefore divergence is guaranteed by this, so check. So the option that we want is option C, because 2 works. All right, and then we don't have to check number 3, but if we did, we would get, the limit is actually infinity as k goes to infinity, so like there's no way that that could converge, so the n-term test works for us. All right, let's take a look at another problem. For x greater than 0, the power series, I'm not really sure why x has to be greater than 0. I don't know. For x greater than 0, the power series x squared minus x to the 4th over 2 factorial plus x to the 6th over 3 factorial minus x to the 8th over 4 factorial plus dot 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 converges to which of the following? So, looking at them, I see 2 factorial, 3 factorial, 4 factorial. I could actually put in a 1 factorial. That feels like e to me. So let's start investigating what e does. So I'm going to write down the series that I've memorized, which looks like this. And then looking at the answer choices, the e to the x1 doesn't really make sense to me, but e to the negative x squared is in one of them. So let's like substitute negative x squared for all the u's and see what we get. So e to the negative x squared would be 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial plus x to the 8th over 4 factorial. This feels really similar to the series that we have, so let's keep investigating that answer choice. So if I do 1 minus this, is going to be 1 minus, and then this whole series that we've written out. And then if I simplify that, I'm going to get, so I won't make you watch that, I'm going to get 1 minus e to the negative x squared is x squared minus x to the 4th over 2 factorial, blah, blah, blah. It is the given thing. So this is definitely the answer. So maybe you look at it and you don't think to do that, right? So what do? One of the options on these sorts of things, because it's multiple choice, is we can look at like what the first terms of the series look like, right? So for example, for A, if I write down the series for sine of x squared, just a couple terms of it, so it's going to be x squared and then minus x to the 6th over 3 factorial, and it goes forever. And then minus the series for cosine is 1 minus x squared over 2 factorial, and it goes forever. If we simplify this, this series would start with just -1. And since it starts with -1, it can't be the answer, right? So we could have crossed that out. If we look at option B, so we're going to do the cosine series and then minus our e series. And again, we're just going to look at what the first terms look like. So the reason I'm going through this is I think this is a good strategy. And sometimes you get problems like this and you're just not sure where to start. So you have to have a couple strategies. Looking at the factorials in the denominator is always a good choice because sine, cosine, and e have different factorials in their denominators. But failing that, looking at first terms is a great idea. So this would start with just negative x, which again can't be right. So that's not it. And then if we looked at d, we would have a similar thing, right? So we would get essentially the series for x times sine of x, which takes the series for sine and just increases the exponents by 1, minus x. That's again going to start with negative x, so again it can't be right. So 2 approaches would have given us the answer, and then obviously if we did it for C, we would get the right answer. All right, let's take a look at another problem. If the sum of a sub n diverges and 0 is less than or equal to a sub n is less than or equal to b sub n, so a sub n is in the middle, and a sub n diverges. For all n, which of the following statements must be true? So this is actually like just half of the direct comparison test. So I know that b sub n diverges. And the reason I knew that is because I know the direct comparison test. So this shows up kind of frequently where you're given like the requirements of one of the tests and you're just asked basically like which test is this. So b sub n has to diverge. So I could just move on, but I'm going to look at the answer choices and just like investigate them. So for option A, -1 to the n, a sub n converges. Well, can we think of something where that doesn't happen? So I need a series that diverges and then the alternating version also diverges. Turns out I decided to start with B. Did not remember that. Why would I do that? But B is like the classic example actually. So the harmonic series diverges, the alternating harmonic converges, so B couldn't have been the answer. This one, I'm going to do the sum of n versus the sum of -1 to the n. Both of those diverge. And then D, obviously there's no examples because that would contradict the direct comparison test, so that can't do it. All right, let's take a look at another problem. What is the radius of convergence of the sum of x plus 3 to the 2n over 5 to the n? So I'm just going to do the limit comparison test. No, I'm not. I'm going to do the ratio test because that's what you do for this. So it's going to be the limit as n approaches infinity, the n plus first term. So we're going to get a 2n plus 2, right? So 2 times the quantity n plus 1 gives you 2n plus 2. So n plus first term times 1 over the nth term. And when I do all my simplifications, I'm going to be left with, actually in this case, I don't really need the absolute value because it's going to be the quantity x plus 3 squared. You could leave the absolute value. It's always safe to do that. And then over just 5. And that needs to be less than 1. So that means that the quantity x plus 3 squared has to be less than 5. But I need to get just x plus 3, like really the absolute value of x plus 3. I can't have it squared, so I'm going to square root both sides, becomes the absolute value of x plus 3, and then is less than the square root of 5, so the radius is the square root of 5, so let's pick that and move on. I guess like for C, you're giving like the width of the interval. For A, you forgot to square root. For D, you just did something entirely wrong. Sometimes it's hard to come up with 4 answer choices. Let's take a look at another one. What is the sum of the series 1 minus the natural log of 3 plus natural log of 3 squared over 2 factorial, blah, blah, blah. All right, so looking at that nth term, you got -1 to the n, natural log of 3 to the n over n factorial. In your mind, make that the quantity negative natural log of 3 to the n over n factorial. That feels like e to me, right? So I'm going to write down the series of e. And again, just look at the factorials, right? So e to the u is 1 plus u squared over 2 factorial, and so on. So I'm going to write that down. Now, what am I subbing in? Well, I'm subbing in negative natural log of 3. So I'm going to let u equal negative natural log of 3. So replace every u that you see with that. That'll give me this. E to the u is negative natural log of 3, blah, blah, blah. All right, so this is the series that I want. Now I just need to deal with e to the negative natural log of 3. So first, I'm going to make that e to the natural log of 3 to the negative first. And the reason I'm doing that is there's a property that says that coefficients of natural logs can become exponents of the argument of the natural log. Then e to the natural log of 3 to the negative first is actually just 3 to the negative first, which is 1/3. The property I use there is that e to the natural log of a is just equal to a, and that's my answer, so I'm going to go with 1/3. All right, let's do another one. If the series S is equal to the sum from 1 to infinity, -1 to the n over n cubed, if that series is approximated by the partial sum from 1 to k of blah, 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 what is the least value of k for which the alternating series error bound guarantees that the absolute value of s minus s sub k is less than or equal to 7 over 50,000? So I'm going to consider this a calculator problem because I don't know what I'm doing otherwise. This is essentially a question about the error, right? The difference between the actual sum and the approximation is the error. And I know that the error is less than the first term left off, but it's really less than the absolute value of the first term left off, or the absolute value of the error is less than the absolute value of the first term left off, or the magnitude of the first term left off. There's a lot of ways to say that. All right, so I need to solve, like, when does this thing, when is this finally true, right? So I'm going to use a calculator. So I use a calculator. Here's a screenshot. I solved 1 over n cubed is less than 7 over 50,000. I got that n is greater than 19.2586. So I have to be greater than 19.2586. So 20 or 21 works, but we're looking for the least value. So the least value for which this is true would be 20. All right, let's take a look at another problem. So we're going to let f be a positive continuous decreasing function such that a sub n equals f of n. If I look at that, I immediately think that that is just the requirements of the integral test. So this is probably a question about the integral test, like can I use it, whatever. I can use it, those are the requirements. So let's see what the question says. If the sum of a sub n converges to k, which of the following must be true? All right, so I think this question is trying to get at one of the misconceptions about the integral test. So we are told that this converges, and that just means that the integral converges also. What it doesn't mean is it doesn't mean that the integral converges to k. We don't know that. We just know that the integral converges. So the limit of the nth term is k. I mean, unless k is equal to 0, that would be a problem, right? The integral diverges, I mean, that's ridiculous. The integral converges, that's going to be the answer, and then d is like the primary distractor on this, where you might think the integral would also converge to k, but it does not. So there's our answer, and this is another one. Like we already saw the direct comparison test come up. This is the integral test. Sometimes they just lay out the requirements, and then you have to decide, based on knowing those requirements. Let's look at another one. Which of the following is not a p-series? Well, this is a weird question. All right, so I mean this one because it alternates. But let's look at. So the question isn't which isn't a what's a convergent p-series. It's just what's a p-series. So for a like might actually be a distractor, right? Because a p-series is 1 over n to the p. So for this one, you would rewrite it as 1 over n to the 3 halves, and then p is equal to 3 halves. And then if you needed to know, that would converge. Here p is equal to pi, which is a weird value of p, but still it's a constant. And then here p is equal to 1/2. So if p is greater than 1, it converges. If p is less than 1, diverges. Well, less than or equal to 1. If p is equal to 1, you get the harmonic series, which is just a famous series. It's like the dividing line. So p is greater than 1, converges. Pi is greater than 1, so converges. 1/2 is less than 1, diverges. And then the one that we circled is not a p-series, but it is a convergent alternating series. And in fact, it's the alternating harmonic. I don't know why I put that in quotes, but it is the alternating harmonic. It's not like otherwise known as. All right, let's look at another one. Which of the following converge? So these are my least favorite type of question, where it's like 1, 1, 2, 1, 2, 3. When the AP exam went from 5 choices to 4 choices, these got a little better because there are fewer options. But anyway, we're looking for which of them converge. All right, so the first one is a p-series with p equals 2/5. 2/5 is less than 1, so we know that this diverges. So 1 is not the answer. So what can we eliminate? We can eliminate this. It's the only option where it showed up. All right, so now it's going to be 2 only, 3 only, 2 and 3 only. So we're going to have to figure them all out. So let's see. The next easiest one is 3, I think. So let's look at that. Pi minus 1 is, so that's 3.14 minus 1 is 2.14, which is less than 2.718. So pi minus 1 is less than e, which means that our ratio is less than 1. And this is actually a very weird looking geometric where the ratio is less than 1, but it definitely converges. So we have convergence there. So now we need to figure out if 2 converges or not. So we could cross out 3 only at this point. No, 2 only. We can cross out 2 only because we know that 3 converges. All right, this is why I don't like these questions. It confuses me. It's not the math. It's answering the question. All right, so let's do the ratio test on this. I mean, factorials grow faster than exponentials, so this is going to converge. But we should do the ratio test anyway. So n plus first term divided by the nth term, or n plus first term times the reciprocal of the nth term, which is what I prefer to do. So simplify everything, we'll get 5 over n plus 2. You really don't need the absolute value because n is approaching infinity, so n is definitely positive. Or you could leave the absolute value, not going to hurt anybody. This is just 0, which is definitely less than 1, which means this converges. So our answer is 2 and 3. All right, let's take a look at another problem. consider the sequence a sub n equals square root of n plus 2 minus square root of n, which is also equal to 1 over the square root of n plus 2 plus root n. I don't actually know if that's true. I didn't check that when I wrote this problem. I think let me check that. Let me see. 1 over square root of n plus 2. I'm just checking this on my computer here. So I'm gonna multiply by the square root of n plus 2 minus square root of n over square root of n plus 2 minus square root. I feel like that 2 is supposed to be there. Let's see. This it's just gonna simplify it, right? All right, hold your horses. Square root of n plus 2 plus square root of n, and then I'm gonna multiply that by times square root. I should have just done this by hand. This would be like way easier. Minus square root of n. Yeah, there should be a 2 in the denominator of that first thing. But we're going to base everything on the second part, the 1 over radical n plus 2 plus root n. So it doesn't matter because that 1/2 would not impact convergence or divergence. So don't worry too much about that. A real question, obviously would have thought about that ahead of time, but I didn't, and I'm 46 minutes deep, so I'm not fixing it. All right, so which of the following is true? So all of these are based on limits, so the first thing I'm going to do is take the limit and see what happens. So the limit as n approaches infinity of this thing, definitely 0. So the limit is definitely 0, so we could cross out anything that doesn't have the limit being 0. So gone, gone. Now we have to decide, does this converge or diverge? Okay, so I look at this and I think it's really related to a p-series, I feel like kind of clearly. I'm going to say this is like approximately just 1 over 2 root n, because if n is really big, that plus 2 isn't really doing anything for us. So it's approximately that. I know what that thing does if I do the series 1 over 2 root n. That's just 1/2 the sum of 1 over n to the 1/2. P is 1/2, less than 1, diverges. So I know that that diverges. So now I could do limit comparison to that. But when you do limit comparison, you're really just doing it because you already know what's going to happen. Like, you're doing it to prove it. So I already know this is going to diverge because it's basically 1 over n to the 1/2. But we're going to keep going. So this, I would get radical n over radical n plus 2 plus root n. And then that limit is definitely 1/2. And since it's positive and it's finite, we can say that they both do the same thing, so this must diverge. So at that point, we can pick our answer. If you would prefer to actually do some work on that, what I'm going to do is divide everything I see by root n. So I will get this, right? Root n over root n is 1. Root n plus 2 over root n is just that. And then root n over root n is 1. And then I'm going to kind of bring everything together in that part right there. Bring them under one radical. Now if you let n go to infinity, so this is just in case you weren't sure where 1/2 came from, that's the work that I would have done. All right, let's take a look at one more problem. I should say also, if you're looking at the PDF, I probably changed the PDF of the problems, but I'm not changing it in the video. So new problem. Which of the following statements is true about the series? So I accidentally, can I undo that? Okay. Which of the following statements is true about the series, the sum from 2 to infinity of 1 over 3 to the n minus 3n? All right, the series diverges by the n-term test. The series converges by the n-term test. So you can see why I cross that out. I'm crossing that out right now, right? No series can converge by the n-term test. That is a test for divergence. Can't happen. All right, the series diverges by limit comparison to 1 over 3n. So that's a little weird, but I guess it's because it's part of the problem is the 3 to the n minus 3n. Or the series converges by limit comparison to 1 over 3 to the n. All right, so let's take the limit and rule out this n-term test thing. Limit as we go to infinity of a sub n is definitely 0. That tells us nothing, so that's out. So now we need to just have a sense of do we think it converges or diverges? Well, 3n 1 over 3 to the n minus 3n looks to me a lot like 1 over 3 to the n, because as n goes to infinity, 3 to the n dominates, and that's why I'm choosing to think of it as 1 over 3 to the n instead of just 1 over 3n. There's too many 3's and n's, but I'm thinking it looks like that geometric series. 1 over 3 to the n definitely converges. So let's see. I'm going to do the limit comparison test, which is what it tells us to do. So I'm going to take the given series, the n term, divided by the thing I think it looks like. Let's flip this. So if I wanted to do work, I could do L'Hopital's rule. I could divide through by 3 to the n. Or I can just look at it and be like, if n goes to infinity, that minus 3n doesn't really matter. So this will be 1. That is positive and finite, which means they both do the same thing. So they both converge. So the answer is going to end up D. All right, so let me circle that. All right, 24 questions. That's a lot of multiple choice practice focused on series. You just have to know like a lot of stuff, but it's not an insurmountable amount of stuff, and the more you practice, the easier it gets. I hope you found this helpful, and good luck.